So I'm finally back with another video. I am going to be working on this Scott 330 vintage stereo receiver again. There's a couple things I still have to look at, and this is hopefully the last day that I'm going to be working on this thing. I have more stuff to work on, like a Marantz stereo receiver, a Crown boombox, a Hitachi boombox, and so on. So I'm a little bit pressed for time. Anyways, I just want to show what else I look at when for example, I repair these things. Like right now, I'm taking a look at all of the fuses here. This has a total of 5 fuses, and it's always good practice to actually inspect the fuses and to actually see if they're the right ratings. Sometimes I've had it before where the absolute wrong fuse has been there. Somebody put it in there, either the rating's too high or it's too low, anything like that. I really don't get too many like they used to be. When I first started working on stereos, you had like a lot of people, they would put like you would use like aluminum foil and stuff like that. I really don't see that much anymore nowadays. But anyways, to stick to my subject, that would be that's always a good practice if you have the time. Check those fuses. And another thing I like to do is I like to check the output from the power supply and see if all the main DC voltages are correct. Like this receiver, for example, here in the power supply, it looks like a plus 31 volts and minus 31 volts. Then it has some voltage regulators. And on this schematic, the voltages are printed. So I always like to check that too. But for way of example, I'm just going to go ahead and check the plus 31 and the minus 31 now. And basically just show how I do that. It's not really hard. Probably the people that work on stuff like this often or all the time, you already know how to do this. And here we have the power supply, and I'm going to check. Here's the 2 main filter capacitors right here. It looks like 6800 microfarads, and here 6800 microfarads. Of course, these are the diodes that convert the AC to DC basically, or pulsating DC. And if we see, if I can't focus out, we can see right here where I'm pointing a screwdriver at, these are the voltage regulators. But I would have to look for them here on the board, and it might take me a little bit to find them. So I'm just going to go ahead and show me doing this here. So of course my meter is in a DC position, and again I'm going to be measuring at the main filter capacitors, and one voltage should be minus 31.4 and the other one should be plus 31.4. Since this is a dual supply power supply and a dual supply amp here, let me go ahead and take a look here. 32.6, somewhere around there. Try the other one. This should be minus coming up here. It's actually minus 33. So both of them are pretty close to each other. Really nothing to worry about. It's a little bit high, but for me, you know, if it's in, say if it's like within 10%, I'll go ahead and I go ahead and I just let that go. Also, you might have to figure nowadays the voltages are higher than they used to. They're not, say, 110 or 220. I think nowadays they're 120 and 230. So correspondingly, your voltages, your power supply voltages are going to be a little bit higher. You can see what happens here when I turn the AC voltage down. Since I'm running this through an isolation transformer, we'll just look at the meter here. Let me see if I can't focus in a little bit better. And if I turn down the AC voltage coming in, the DC output here should go down too, and it actually is. So that's basically what I'm talking about. Now here's one of those two spots we just took the DC voltage measurement, the DC coming from the power supply. This is one of the large filter capacitors. If we wanted to, we could also hook a scope across here and take a quick look at the ripple, for example. I can do that real quick before I move on to my next subject. Of course, the scope is in the AC position, and we of course measure across the positive side of the capacitor. Let me go ahead and get the scope set up. So I just soldered a piece of wire here on this solder point, and I'm just going to go ahead and connect the scope so I can get a measurement, because I can't hold the probe on here and hold the camera at the same time. That's not going to work out. Of course, the power is off now. I wouldn't recommend doing this with the power on. You have to do it with the power off. And now we can take a look at the ripple. Again, the ripple is just the AC voltage that's riding on the DC voltage coming out from the power supply. The less AC voltage we have, the better. I already know this is not going to be very much, because if I turn this receiver on and I turn the volume all the way up, there's not very much hum, if anything. So let me go ahead and turn everything back on and we can take a look at the scope. And here is the ripple. That's about 170 millivolts peak to peak. And if I were to translate that to RMS voltage, I'd venture to say that's going to be less than half of that. So it wouldn't even be like, it would be under 85 millivolts. So basically it's not very much at all. And the other channel should be about the same too. So next thing I'm going to do is do the idle current here, called the bias adjustment. It says here connect 8 ohm resistor to speaker terminals, switch the speaker terminals on. Volume control fully counterclockwise means the volume controls all the way down, which is normally how this is done anyway. Turn RB7 fully counterclockwise, that's the potentiometer. So that means that has to be turned down too. And then you can use a digital voltmeter and you connect the probes across R219 and R221. That means R19 and R221 at the same time. Let the unit warm up. Okay, and adjust RB7 for 40 millivolts across the resistors. Okay, and what do we have here? We go over here. Okay, we can measure the current too instead, but I think we have to remove something, so that's too much work. So we're going to go ahead and do the voltmeter method. And here I printed out the adjustment diagram, and we can see right here for the left channel, connect between this resistor here and this resistor, and same thing for the right channel. Of course, we do the adjustment once for the left channel, once for the right channel. And the voltmeter, of course, is going to be a DC voltmeter. So actually it's a pretty straightforward job. So I've been looking for the resistor to hook the voltmeter up to, so I can do the adjustment, but I can only see one resistor, this one right here, this big fat one I'm hitting with the tip of my screwdriver. I mean, the other ones are going to be underneath this plate here, so I have to take this plate off completely, which is a little hassle. Okay, I got the plate off, and here we can see the other resistor. There was one in front on the other side, and to the left of this resistor, which you can't see now, there are two resistors for the other channel. So at least I was able to get to those. So I have everything hooked up. I have a dummy load hooked up to the speakers. I've got an oscilloscope probe hooked up across the dummy load, and I've got the voltmeter, the DC voltmeter, hooked up across the resistors of one channel. Here's one resistor right there that I'm poking at with the chopstick, and the other one is, you can't see it there, it's down behind there. I'm just going to go ahead and show this one channel because this is easier than the other channel. The other channel I've got some figuring out to do, where to exactly hook up the voltmeter probes to the resistors. There's one resistor right now that I'm touching, and the other one's on the other side, so I have to look at the schematic or go ahead and follow the traces. But I don't have very much time now. I need to get this video done quick, so I'm going to go ahead and just show this one channel, and it's supposed to be reading about 40 millivolts, and we can take a look at the voltmeter, and right now it is 48 millivolts DC or 49 millivolts DC. So I'm going to take it down a little bit, and here's what we adjust that I'm touching right now with the chopstick. Now with the camera I'm coming from the back of the receiver, not from the front. So I'm going to go ahead and adjust this, and just to show what kind of tool I'm using to adjust that potentiometer, it's a ceramic screwdriver, and we can see here what I've got it adjusted to now. So I've managed to get the voltage down to 40 millivolts DC, and or actually I'm pretty close, so that's good enough for me now. But just for the fun of it, I mean, I have this channel adjusted, but notice what happens when I turn that bias potentiometer. If I go ahead and turn that up, this is what you're looking at now, is the current that's being drawn by the whole receiver. So I'm going to go ahead and turn it up. You can see there what's happening. The current is actually going up. What I'm going to do now is remove a burned out light bulb. These light bulbs are 14 volts. They run off of AC. They run off a transformer winding, and I think they're 80 milliamperes, and they can be found on eBay. What I'm going to do here is cut this wire off flush, because as you can see here, there's like a rubber grommet which has gotten hard with age. So even if you're careful, it might still fly apart. And inside this rubber grommet is a little insert, and the bulb fits into the insert. So I'm going to cut this off, remove as much of the old glue as possible, and then probably use this chopstick to push the light bulb and everything forward. I'm still battling this bulb here and the bulb holder. I removed some of the glue and tried to push it in, but it wasn't enough, so I ended up removing this bracket here, which holds the light bulb holders. They're just held in there by two Phillips screws. There's one right there and one's on the other side. And I've been twisting on the bulb here, and the bulb came out. You can see here the grommet, and you can maybe see the insert way down in there. So I've got that far yet, and now I'm going to slowly try to remove the insert or push the rest of the bulb out, either one or the other. I managed to get the bulb pieces out, and you can see the insert right there and the grommet, and I use this little sharp tool which I was able to poke in there. You can't really like leave the insert in the grommet and the bulb in the grommet and try to twist it out. You're just going to end up, this rubber is so brittle, you're just going to end up breaking it. So it takes a little bit longer this way. So the last thing I'm going to do is check out all the solder joints, see if they're okay, and remove like traces of glue here. I've got these little plastic spatulas, and I can remove that, and then I'll go over with isopropyl alcohol And basically that's about it. I'm sorry I wasn't able to spend more time on this video, but I am in kind of a hurry. So I just wanted to show a couple things that I did or normally do or sometimes do. Anyways, thanks for watching.